Quantectum stress forecasting system. Earth's crust is cut by numerous faults. Usually, faults tend to grow in such a way that they form subparallel sets. Different fault sets can be present in a region forming a fault system. We distinguish between three main types of faulting: normal, reverse, and strike-slip faulting. In the case of normal faulting, the upper block slides downward. The Earth's crust becomes thinner. In the case of reverse faulting, the upper block slips upward. Consequentially, the Earth's crust becomes thicker. When the strike-slip faulting occurs, the two blocks slide one past another in the horizontal direction. Such deformation does not produce any thinning or thickening of the crust. Moving tectonic plates exert significant stresses on the faults, thus producing slip along with them. The slip along a multiplicity of faults leads to a contraction in one direction and extension in the perpendicular direction. This process is known as the multiple slip mechanism of tectonic faulting. Alongside contraction and extension in a region, significant rotations can occur in the case when slip only happens along one fault set. These are so-called regional macrorotations. This type of rotations must be distinguished from the rotations of blocks between the fault planes, which are called microrotations. The difference between the macro and micro rotations is called the relative microrotation. Blocks of rocks between fault planes do not rotate, which leads to non-zero relative microrotation. The regional macrorotations are only absent in the case of slip along with symmetrical fault systems, for example, the conjugate fault systems. During the seismic slip or earthquake along a fault, seismic waves are emitted in such a way that we can reconstruct the type of faulting mechanism leading to the earthquake. To illustrate the three possible faulting mechanisms, we use the so-called beach ball stereograms and different colors. The reverse faulting is illustrated with red, normal faulting with blue, and strike-slip faulting with green color. Because thousands of earthquakes are occurring at the tectonic plate boundaries, we can calculate the total faulting-related deformation and stress. These calculations are constantly performed by the Quantectum stress forecasting system. There are three main products being calculated by this system. First, charts of the relative vertical deformation illustrate the relative thickening or thinning of the Earth's crust. Large red areas indicate the prevalence of reverse faulting and hence thickening, while the large blue areas indicate the prevalence of normal faulting, where thinning of the crust occurs. The green color indicates the strike-slip faulting. Second, charts of the normalized tectonic shear stress along active faults can be produced, indicating regions of low shear stress in blue and green colors, and regions of high shear stress in red and black colors. Our observations show that large earthquakes with magnitudes above 7.5 occur with increased probability in regions of high shear stress. This is extremely important information for the seismic hazard estimations. Third, charts of the maximum horizontal compression or contraction, and charts of minimum horizontal compression or maximum horizontal extension show how the tectonic plates move during some time. The stress forecasting system is one of several important modules of the Quantectum earthquake forecasting system, and provides important information on the global plate tectonics.